Devlog time? I think so. Yeah, welcome back to Devlog 4. I'm glad to see you again. If you don't know me, I'm Tom Crow and I'm an indie game developer, and I'm currently working on my first major game, which is called Beastgang. This devlog took quite a while. This was mostly because I had to study for my university exams. I also managed to get sick for like a whole week, which was not very fun. But let's get right into the devlog. The main feature I added was the font renderer, mostly because when you develop a story-driven game, you need some kind of tool that lets you draw text on the screen, and that's kinda hard if you don't have a text renderer, so I made one. So now to render text, you need some kind of font, because it will be kinda difficult to try to render text without actually having any font to render. So you do that by giving the framework a path. It will then take that path and load two files associated with it. One is the font image and one is a font file. The image is kind of self-explanatory. It's just an image with all the single characters written onto it. And then you also have the font file. The font file basically specifies the spacing between each character and where each character is located on the font sheet. So yeah, now that we have the font sheet, we have both an X and a Y coordinate and also a scale for every character. So now let's say we want to select a G. We will look into the table of all characters that are in this font, and if we are able to find that G in the table, we will select it, and it will like actually select the coordinates on the texture using the data from the font file. Now we have it selected, and that means that we can actually draw to the screen. And if you do that consecutively with a bunch of different letters, you can type out text to the screen. Now let's continue and get right to the font renderer. But before we can talk about the font renderer, we need to talk about the font parameter. These are basically just a bunch of parameters that define the context of the font renderer. There are a bunch of different things, most importantly what font you are using, meaning that there are a bunch of different fonts you can dynamically switch between as you wish. Then you also have colors, which include primary and secondary colors. I'm just gonna leave them up here on the screen, you'll see them come into use later. Now you also have a bunch of drawing modes. These are kinda cool because they let you decide how you want your text to look. So you can draw text normally, you can make it look bold, you can give it a shadow, or you can give it a bunch of outlines. And right here you can also see the different colors come into play. Now let's continue and get right to the font renderer. So next up we have padding. Padding should also be pretty self-explanatory. It's basically just the spaces between your text and the borders of the text box. And then you also have alignment. Alignment is for putting the text either to the left side, to the right side, or to the center of the screen. So you can easily move it around as you wish. And then there's also a feature that I call Smart New Line. This one is really neat because it automatically splits up your text into like smaller chunks and puts each of these chunks into like a separate line. It basically does that by taking into account where the last space in your line is, and then it slices that off and puts it into the next line. And it does that repeatedly until your text is properly spaced. It also takes all the leftover spaces into account and removes them from your text. This is important because they will mess up your text spacing if you don't deal with them properly. So you also have a bunch of effects. These are pretty nice because you can make the text look like somebody is like shaking or screaming, and these two also look really fancy. So let's get to the next part, tokenization. So what I call tokenization is the process of embedding small pieces of data into your text. And this data is not actually printed to the screen or anything, so when you play the game you can't actually see it. But it can be used to dynamically change the behaviors of your text, mostly by changing the font parameters. So yeah, here's a little example. So here you can see a token with the prefix C, and you can see right here in the game that it changes the color of the text while it's being rendered out. There are a bunch of different ones. I'm not gonna go over all of them, but you can also change stuff like the text mode or the effects of the text. And you can even like embed small images, which will automatically scale to the size of your font. I already managed to include the font renderer into a bunch of different things. For example, the UI system now uses the font renderer instead of static images for text. And I also implemented a lot of other cool features like labels, which are basically just text boxes that fly above a certain entity you bind them to. There are also dynamic text boxes that will scale with the size of your text. And I created a specific rendering function for boxes that will take in a sheet and splice it up in a way that will perfectly match the size of the box. Adding a font renderer to my game was an essential building block in developing my framework, because a lot of future features will build upon that, especially the next update, which will revolve around adding a dialogue system to my game. So next up in the list is the combat system. So yeah, combat is gonna be, like, it's pretty cool, but right now it's still too new to actually implement anything cool with it yet. Well, first of all, you have a character, and that character has to have some kind of stats associated with it, right? So right now it has two things. One of them are the base stats. The base stats are basically just a small object that holds all the different stats that you have. For example, health points, attack points, defense points. And you also have talents. Talents can do a bunch of different things. For example, unlock new abilities, which also includes passive abilities, or they will simply boost your stats by a specific amount. Now, let's say you attack somebody and you wanna find out how much damage you want to deal. You go into the stats and ask it how many attack points do I have, and then it will take the value from the base stats and sum up all the attack points that you also get from the talents and add them together to get the total amount of attack points that your character has. But it's kinda boring if you have a bunch of stats but don't really have any use for them. So that's where the casting system comes into play. Right now it works by your player character having something called a caster. This will be able to take input from mouse and keyboard, and in the future also a controller. And it will then search for a bunch of castables that are below that, and these will have different types. For example, a default one, a weapon one, or like a bloodline for like magic abilities, and they have an ascending priority. So the one with the highest priority will be picked first. So how this works in practice will look like this. You have a caster, and let's say, for example, it detects that you press the left mouse button. So it will start firing a default attack. It will firstly look into your bloodline and check, hey, do you have a default attack? And if it doesn't, it will go one priority step down and check if the weapon also has one. And if it finds out that the weapon has an ability for the default attack, it will then go on to cast that ability. And to make it even more complicated, abilities themselves are also a type of object, and they have a bunch of functions. Most importantly, the cast function, which will actually cast the ability, but you won't just call the cast ability and then be done with it. First of all, you have to call the can cast function. This one will tell you if you're even able to cast that function. For example, if it has a mana or like stamina cost associated with it and you don't have the necessary requirements, or maybe you simply don't have the ability unlocked yet, it will then tell you that you're not actually able to cast that ability. So now let's say you actually got to the point where you were able to cast an ability, then you will call not the cast but the pay function. This will manage all the costs that are associated with casting the attack, mostly like mana or like stamina cost. And after you paid all of those, this is why it's called a pay function, it will go on to cast the ability. So now you have two functions left. The first one is the cancel and the second one is the force cancel. They are practically the same. The only difference is that the first one can be empty. For example, if you have an ability that is not cancelable through enemy attacks. And the second one is for stuff like cutscenes where no matter what attack you are using, you always have to cancel it. Even if it's an ability that can normally not be cancelled by outside factors. Now let's see how this looks in practice. Right now, we only have a single castable, which is the default one. And for testing purposes, I gave it an ability that is hard-coded into the castable, which will right now only damage the player, because we don't actually have any entities to attack right now. Honestly, this kinda sucks ass. But I honestly think that's completely fine. Because in the future we will use this structure to add weapons and other abilities to expand the player's skill set. So I'll definitely advise you to watch my future devlogs if they ever come out. Well, that was everything for this devlog. I hope you enjoyed watching it. And if you did, I would really appreciate it if you give it a like. And with that, I wish you a good rest of your day.